All right, let's take a look at trapezoids. Trapezoids are defined really by just kind of two main characteristics. Trapezoids have at least one pair of parallel sides. Now remember, I said at least one pair. So that means that all parallelograms are trapezoids, which also means that all squares are trapezoids, rectangles are trapezoids. Rhombus is a trapezoid. Trapezoids usually look like this. Usually they only have one set of parallel lines, but in this case, trapezoids, based on Ohio's Common Core, are defined by a quadrilateral that has at least one pair. So usually it's one, but it's really at least one pair, and then the angles on the same side of the base are also supplementary, which means these two added together is 180, and these two added together to give 180, but there's no real relationship between this guy and this guy and this guy and this guy. And again, that has to be true. Just remember, this can be viewed as a transversal. If this line is parallel to this line, then these two angles here, well, they're just alternate interiors, and we know that alternate interiors are supplements. Again, that goes back to Unit 3 or something when we looked at transversals. So we know that these are alternate interiors and these are alternate interiors because we know those are parallel, and so these are supplements and these are supplements. Again, I want to emphasize this again. Trapezoids are one pair, at least one pair of parallel sides. And so parallelograms happen to have two, rectangles two, squares two, rhombuses two. And so all of these guys are parallelograms, but all parallelograms, which include these guys, are indeed trapezoids. Trapezoid just has at least one, again, so all of these are considered trapezoids. All the properties of a trapezoid are filtered down. Again, these are the just kind of two properties, really. One set of parallel lines, it has to have at least one, and then these and those are supplements. And if you keep going down, you get more and more distinct characteristics. Parallelograms have to have two. Again, there are people in the world that define trapezoid as exactly one, but the way we define it is it says it's at least one. So that means all of these guys are indeed actually trapezoids. Okay, so it's not too hard to be a trapezoid. How do you prove something's a trapezoid? Well, you just prove that it's got at least one set, or if you just prove it has one set, then it is a trapezoid. Okay? Now, if you're an isosceles trapezoid, that's another leg up in terms of the definition. So an isosceles trapezoid, again, these are the bases, just like a parallelogram. These are the legs. So an isosceles trapezoid not only has at least one pair of parallel lines, but these guys are congruent, and they're what we call the legs. Now, when the legs become congruent, just like an isosceles triangle, if you draw that, think of that isosceles triangle, those base angles, well, they're also congruent. And it makes the diagonals congruent. So an isosceles trapezoid is a big step up. It adds the fact that we now have congruent legs, we have congruent base angles, and we have congruent diagonals. Much more characteristics than a simple trapezoid. Okay, the area of a trapezoid is 1/2 height. 1/2 times the height times b1 plus b2. That's the standard way. I like to think of it as it's the height times the average base. Now remember, if you take b1 plus b2 and divide by 2, you get the average base. So it's the average base times the height, similar to a parallelogram. Okay, parts of the trapezoid is just kind of a diagram down here. Again, those are your bases. Here are your legs, and then the diagonals are in yellow. And then we have another term called the mid-segment, which is the segment that connects the midpoint of AB and CD. Okay, so you can kind of read over that. I'm sure you downloaded this already. Now let's scoot this up. We do have the mid-segment theorem, which is a really easy theorem. It just says that the length of the mid-segment, EF, is equal to half of AD plus BC, which really just means that the mid-segment is is the average of the two bases. So take B1 plus B2 and divide it by 2, and you'll get the length of this mid-segment. Okay, so that's the mid-segment theorem. Proving a quadrilateral is a trapezoid, that's really easy. You just got to show me that it's got at least one set of parallel lines. Proving it's an isosceles trapezoid just goes one step further. Show me that it's a trapezoid, and then show me that the legs are congruent. Again, how do you show the legs are congruent? Show me the same length. How do you do that? We use the Pythagorean theorem. We almost always use the Pythagorean theorem to find the length of something. Or you can do these things. You could show me that it's got a set of parallel lines and the base angles are congruent, because if these base angles are congruent, then you know that the legs have to be congruent as well. Or you can show me that the diagonals are congruent, because that will force the base angles to be the same, and as well the the legs to be the same. Again, number one by far is the most popular. Show me it's a trapezoid and show me it's got congruent legs, then you know it's an isosceles trapezoid. Okay, so we're going to look at some examples of trapezoids, do some quick examples, and then I'll turn you loose and you can try the worksheet on your own. Okay, so let's just draw some. Let's just take, I don't know, something that might look something like this. Let's say this is 6. Let's say that is 10. And let's say then the height is 5. Okay, let's find the area. The area is 1/2 times the height times b1 plus b2. You can do this in any order you want. If you want to do 1/2 of 5, that would be 2.5. And then 6 plus 10 is then 16. And then what, 2.5 times 16 is 40. So that would be like 40 square feet. Okay? What if instead I had something, oh, that is a terrible trapezoid, but I'm not going to redraw it. Let's say this is 12 and this is 6. And what if I knew also that the area, somehow was 66 square feet? How would I figure out what that top base was? All right, let's just call that B. Well, then we could say then, if we want to write out the formula in the abstract, 1/2 height B1 plus B2, and then we could just fill in. 66 has to equal 1/2 times the height of B plus 12. So that's 66 equals 1/2 of 6. Let's just make that a 3. B plus 12. Let's divide both sides by 3. 66 divided by 3 is 22. And then we get B plus 12. And we get the base must equal 10, and that would be in feet. Okay, so something like that. I can give you areas, I can give you heights and bases, and you can solve for all those things. How would you prove, let's say I have a coordinate system. Okay, let's say I have this point, and this point, and this point, and that point. How would you prove to me that this is a trapezoid? Well, what would you have to do? Okay, so I give you some coordinate grid, and you just need to find the slopes. If you want to prove to me this is a trapezoid, you want to show me that this is parallel to that, and you want to find the slopes. Remember, the slopes is just looking at the rise over the run. So you're going to do something like dot, 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 dot. Okay, and then show me those. So this could be like 2 and 5 and 10 and 4. Okay, both of these would have a slope of 2/5. So then you know they're parallel, and so now you know it's a trapezoid. How would you prove to me it's an isosceles trapezoid? Well, then you'd also want to show me that those are congruent. Okay, so you'd have to do something like dot, dot, dot. Oops. Yeah, that's fine. Actually, dot, dot, dot. Down. That's a really skinny triangle, and then this guy. And then you could do a squared plus b squared equals c squared, and you want to show me that those lengths are the same. Like this is the square root of 40 and this is the square root of 40. If they're not the same, then it's a trapezoid, just not to be an isosceles trapezoid. So you're going to have to prove to me whether things are trapezoids or not, isosceles trapezoids or not. You're going to have to find the bases if I give you areas or if I give you heights, things like that. And then you're also going to have to do maybe like a mid-segment question. So what if, so I tell you that these are parallel, which means you know it's a trapezoid. And let's say then you knew that this was 8, and you knew that was 13, and you wanted to find that other base. Well, you know, again, I would have to also, I guess, tell you that that and that and that and that are congruent, which means I've defined this pink for sure as the mid-segment because it is the segment that connects the two midpoints of the legs. But you know that the mid-segment, 13, has to equal half of base 1 plus base 2. So you can do stuff like that. In this case, I would just multiply both sides by that 2. So 26 equals 8b, and then divide and get 18 equals b, where b is this base. And you can see that 13 is the average of 8 and 18. Okay, so we got the mid-segment theorem. We have proofs about trapezoids and isosceles trapezoids. We find the area of trapezoids, and if I give you the area, you can find bases and heights, stuff like that. Hopefully this gets you started on trapezoids, and good luck.